Hey everybody, Skills and Foundations, ASGF Lesson 6, Writing Equations of Lines. You guys, we're going to write the equation of a line given the slope and a point, or given 2 points, or using point-slope form. Actually, using point-slope form. We're also going to graph equations of lines in either slope-intercept form or point-slope form. So, the difference between point-slope form, point-slope, and slope intercept is actually quite different. Okay, I'm going to lay it out here. And how they're different is that the point in point slope is given by y1, x1, and the slope in point slope is given by m. So in order to write an equation of a line, I either need a point and a slope, or I need the what's called the y-intercept and the slope. So in slope-intercept form, again, the slope will stand for m, and the y-intercept is b. And the y-intercept is where x equals 0. So the point 0, comma b is the y-intercept where the slope is m. So we're going to use these equations, these formulas, to build equations of lines in two different possible forms. Now, the advantage of point slope as opposed to slope intercept is that you can have any point for point slope, whereas you need one specific point for slope intercept, and it is the y-intercept. So you'll see that it's more advantageous to use point slope, but you can also use slope intercept in many scenarios as well. All right, let's get started. All right, so as noted on the previous page, here is slope intercept y equals mx plus b, and here is point slope y minus y1 equal to slope, or m, times the quantity x minus x1. So let's get to it and use it in a few examples. Okay guys, so funny, haha, not really. Mr. Ludd sketched out this entire page, talked the whole time, and forgot to press record. So I'm going to zoom in here and do a little explaining. Okay, so let's look at our first example. We've got the equation y equals negative 2x minus 3. This is going to fit the slope-intercept form where y equals mx plus b. Clearly, m in this case will be the coefficient of x, which is negative 2, and b will be a negative 3. Therefore, our equation, or our line, goes through the point 0, negative 3. That's the y-intercept with a slope of negative 2. So here's the point 0, negative 3, and a slope of negative 2 means we would travel down 2 units and right 1 unit. I've located this point 1, negative 5, and I sketch a line going through both points. This is the graph of the line y equals negative 2x minus 3. Okay, let's continue on to part B. Part B is unique. It's written in a very different form. However, it is going to utilize the same slope-intercept equation. So I've got y equals mx plus b. Notice that now the mx term is moved over here to the right, and the b term is moved over to the left. Therefore, our slope is negative 3/2, and our y-intercept is the point 0, 4. So I'm going to utilize 0, 4 as my y-intercept. I locate that by traveling up 4 units from the origin. This is the origin, 0, 0, up 1, 2, 3, 4. There's the point 0, 4. Our y-intercept, our slope is negative 3/2. Thus, I travel down 1, 2, 3 units and right 1, 2 units. The point 2, 1 is another point on our line. And there we go. We sketch that graph. Let's look at the third example. The third example is in point slope form. I have y minus 2 is equal to 3 times the quantity x plus 1. Now real quick, I'm going to rewrite that as y minus 2 equal to 3x minus a negative 1. And I'm going to show you why I did that in just a second. Okay, this is going to fit point slope form, which is y minus y1 equal to m times the quantity x minus x1. Okay, we can see that y1 is a 2. We can see that m is a 3. But what is x1? Is x1 1 or negative 1? Well, if I put it in this form, x minus a value, just like I have in its generic form, we can see that x1 will be negative 1. So I know now that a point on the graph will be negative 1, 2, right? I see negative 1 and a positive 2 for x1, y1, and a slope of 3. So I plot negative 1, 2, and I plot a slope of 3. So I go up 1, 2, 3, and over 1 unit, putting me at 0, 5. Thus, I can draw the graph of the line y minus 2 is equal to 3 times the quantity x plus 1. There you have it. Let's move on to some more examples. All right, here we are asked to write an equation of a line that goes through the point 7, negative 3, and has a slope of negative 4/3. So I have a point, and I have a slope. Therefore, I'm going to choose to use point slope form. Because this point is not the y-intercept, I'm not going to use slope-intercept form. So it's as easy as this, you guys. I'm going to take y minus the y value I'm given is equal to the slope times the quantity x minus the x value that I'm given. And it's as easy as that. I'm just going to simplify, subtracting a negative value, which makes it y plus 3 is equal to negative 4/3 times the quantity x minus 7. You're not asked to go further, therefore you are complete in writing the equation of that line in point slope form. Let's do another example. Okay, in this example, I'm asked to write an equation of a line, but I'm given 2 points and no slope. So if I need to find a slope to use one of these two equations, I'm going to use both points and find the slope. So the slope will be y minus y over x minus x. So our slope will be negative 3 over a positive 6. So the slope between these 2 points is a negative 1/2. So now I have a slope. Okay, so at least I've got that going for me. But now I need a point. I need either a point or a y-intercept. As I look at my points, neither of these two are y-intercepts. Therefore, I have to use point slope form using either the red or the blue. Thus, I'm going to go with the blue in this case and take y minus a negative 3 is equal to the slope times x minus a positive 1. That would be one possible answer. Or if you chose to use the red point, you could take y minus the y value is equal to the slope x minus the x value, and then go ahead and plug in your x and y values. That would be a correct answer in either case, which would be equivalent to the equation of a line that passes through those 2 points. All right, let's look at another example. All right, this example, again, asks us to write the equation of a line that has a y-intercept of 0, negative 3, and a slope of 1/4. Now, naturally, whenever I see y-intercept, I'm going to typically just go ahead and use slope-intercept form, and that's totally fine, and I would jump right into that. So in this case, y equals mx plus b would tell me that the slope is 1/4 and the y-intercept is negative 3. Thus, the equation of my line would be y equals 1/4 times x minus, I'm going to write that in blue, minus 3. There you have it. That is the equation of that line. I could, if I wanted to, use point slope form And that's totally fine. You can choose to do that as well. That would be y minus the y value, which would be a -3, which would be equal to 1/4 x minus the x value, which would be 0, which in this case, I'll just show you, would be y plus 3 equals 1/4 x times, if I distributed 1/4 times the x and 1/4 times 0, I would get 1/4 x. And then if I subtracted 3, I would get 1/4 x minus 3. Thus, I get the exact same equation if I were to bring that back to a slope-intercept form. Either way you go, this answer is entirely correct, and so is this answer right here. Okay, let's look at a couple more slides. Alrighty, example 2 here says to find the equation of line AB from its graph. So as I look at its graph, two things I need to know. I definitely need to know the slope, and I definitely need to know a point. Now that point could be potentially the y-intercept, if I'm given that, okay? Or it could just be any old point. I do see the y-intercept is the point 0, 2, but I also see a couple other points, point A and point B. So in this case, I have my choice of slope-intercept or point slope. Let's start by finding the slope of line AB. So the slope is going to equal the slope between A and B. Let's determine their points. It looks like B is 3, 3, and it looks like A is -3, 1. So if I found the slope, that would be y minus y over x minus x. So in this case, the slope of this line looks to be 2/6, which is 1/3. I can choose to use A, which is -3, 1, or B, which is 3, 3, or the y-intercept, which is 0, 2. I can see it right here on the graph. I'm going to choose to go with the slope-intercept form. Thus, the equation would be y equals the slope, 1/3 times x, plus the y-intercept, which would be 2. If I chose to use point slope, let's say I used A, that would be y minus 1, which is the y value. The slope, 1/3 times x minus the x value, which would be a -3. So that's utilizing point A. Utilizing point B, I would use the point 3, 3, which would be y minus 3 is equal to 1/3 x minus 3. And thus all three of these answers would be the same line in 3 different forms. All right, 2 more slides. Let's do it. All right, example 3 says write an equation for the line with slope 2. Okay, that tells me right away my slope is going to equal 2. That passes through the midpoint of the segment that has endpoints -1, 11 and 5, 4. So I want my point to be the midpoint of, let's call this AB. Okay, so I'm going to call this point A and this point B. So I got to find the midpoint of AB. Let's find that. Let's take the x values. Remember, midpoint is add the x's, divide by 2, add the y's, divide by 2. So it looks like my midpoint would be 4/2, which is 2, and 15/2, which is the same as 7.5. So when I come out with this point, I see this is just a regular old point. It's not the y-intercept. Therefore, I'm going to use point slope form. Right, I'm using that because this point 2, 7.5 is not the y-intercept. I use point slope form. So I'm going to take y minus y, which would be y minus 7.5. Remember, the 7.5 came from this 15/2, is equal to the slope times x minus the x value. The x value here is 2, right? This slope is right there. And there you have it. That is the equation of the line that has a slope of 2 and passes through the midpoint of segment AB. All right, one more slide, guys. Let's get to it. All right, this one's beefed up a little bit. Very similar to the last example. We want to write an equation of a line that goes through the midpoint of those 2 points and is perpendicular to this line. So I want my slope to be perpendicular to -3. So I want my slope to be a positive 1/3. And I want my point to be the midpoint of, let's mix it up here, get crazy, of xy. I'm going to call this point x, and I'm going to call that point y. So the midpoint of xy, what would that equal? Well, that would be x plus x, which is 8 plus 2 over 2, and y plus y over 2. So that point would be 10 over 2, which is 5, and -8 over 2, which is -4. So I've got a point, and I got a slope. I can now, because that point is not the y-intercept, again, I'm going to use point-slope form. So y minus a number equals the slope times x minus a number. The slope is 1/3. The y value is -4. So I'm going to make that a y plus 4. And the x value is a 5. Okay, guys and gals and all you folks out there, that is it for lesson number 6. We will see you in the next video. Have a great day.